22. In this question paper, we are going to discuss the meter bridge experiment. So, can we move to the question paper? Here we have a 6-mark question and there are 4 sub-questions in this. Okay, the first question is write down the Wheatstone's bridge principle. Okay, we have to write down the Wheatstone's bridge principle. What is Wheatstone's bridge principle? Yes, that is P by Q is equal to R by S. Here PQ and RS are resistors. Okay, so can we move to the second question? Right, the second question is a meter bridge circuit is given below. Using this circuit, derive an expression for finding the unknown resistance. Here, in our question, there is a Wheatstone's bridge principle, means circuit is given and we have to derive the equation for finding the unknown resistor. So that here we can see a 1 meter wire is connected between A and C. Okay, in a meter bridge there is a 1 meter metallic wire, that means 100 centimeters are there, and in other side of the wooden block we can see 2 gaps. First gap is here X is connected in this, that means this is the unknown resistance, and in second gap we have a non-resistance R connected, and from the center, that is from B, we are connecting to galvanometer, and from galvanometer we are connecting to jockey. Jockey is a sliding contact. Okay, and from one side of the meter bridge we can see a connection, that is the cell is connected, the positive of the cell is connected to one end and negative of the cell is connected to the other end. Now our circuit is over. Okay, now we have to derive the expression for finding this X, that is X is the unknown resistance. So first of all, what we have to do? So this is the question and the answer you have to write. First of all, we have to write down the principle used in this Wheatstone's bridge, then write down the procedure, how we are doing that. Okay, so you can pause the video and write down the question and answers. So, how we can answer this? First of all, we will write the principle, that is Wheatstone's bridge principle is used in this meter bridge. Okay, and how we will do the experiment? First of all, we have to do the connections as shown in the figure. Okay, after that we will close the circuit and we have to introduce a non-resistance, that is a small resistance from this resistance box, that is from R. We will remove one small resistance from R and then we have to move the jockey until we are getting a zero deflection in the galvanometer. So whenever we are moving the jockey, we can see the deflection in the galvanometer. Okay. And when it shows 0, then you can stop moving and take the measures, that is, here we can see that A, D, that is L. So here we are getting the null deflection point, that means 0 in galvanometer. So that length we are taking as the balancing length L. Okay, and here we have a 1 meter wire, so that the rest of the portion will be how much? Yes, that is 100 minus L, because this is total 100 centimeters and this portion is L. Right. So what will be the other portion? That means BC, that will be 100 minus L. Now we have to apply the Wheatstone's bridge principle, that is P by Q is equal to R by S. Here we have 4 resistors. Okay, so first one we can see here X and second one is R, and in this side we have L. So we can calculate the resistance here, and 100 minus L is also another point. Here also we can find the resistance. Okay, then we can calculate the unknown resistance by using Wheatstone's principle. Okay, is it clear? Here, what will be the resistance of AD? That means the length is L. Then we will get the LR as the resistance of AD. Then, what about the resistance of DC? That is, here the length is 100 minus L. So, 100 minus L into R. That is the resistance of the wire DC. Okay. Now, we can substitute the values in Wheatstone's bridge principle. That is, P by Q is equal to R by S. So, what we will get? Instead of P is this side, we are taking this resistance, that is LR, divided by Q is this 100 minus L into R. So 100 minus L into R will be equal to R by x. Which one is r? Here x by r. Okay, so this x value we are going to find out. So what we will get? This r and r will get cancelled. Then what is remaining here? L by 100 minus L will be equal to x by r. So how we can find x? We can cross multiply. Okay, so x into 100 minus L is equal to L into r. So that we will get x as LR divided by 100 minus L. So this equation is important that you should remember. Okay, so this can be used to find the values in the case of experiment of Wheaton's bridge also. So unknown resistance x can be calculated by using LR by 100 minus L. Okay, so by knowing the values of L and R we can find x. Is it clear? Now we can move to the third part of the question. The question is, in the above circuit, the balance point is found to be at 40 cm from end A when the resistance is of 12 ohm. Determine the resistance R. Okay, here what are the quantities given? The quantities given are the balancing length L is given as 40 cm and the resistance is given as 12 ohm. Okay. So we have to calculate the unknown resistance R. So which equation can be used? This is a direct question of Wheaton's bridge principle, right? That means x is equal to RL by 100 minus L. We know R and L. So simply we have to substitute the values of R and L here. Right. So what we will get? Here R is 12 and L is 40. So we can substitute the values. So that will be 12 into 40 divided by 100 minus L, that is 100 minus 40, that will be equal to 12 into 40 by 60, isn't it? So what we will get? That will be 8 ohm. Clear? So that is a numerical direct question, so please don't leave the question. Okay, now we can move to the last part of this question, that is, would the galvanometer show any current if the galvanometer and the cell are interchanged? The question is, if suppose we are interchanging the galvanometer and cell in the circuit, so is there any change in the deflection in the galvanometer or current in the galvanometer? That is our question. Is it possible to have a change in the deflection or in the current? No, even if we are interchanging the cell and galvanometer, we will get the same value of current. That means no change in the galvanometer reading. So we have almost finished the 4 parts of the same question. Okay, so that was a 6-mark question and it is very easy to solve. I hope it is clear to you. Now we can conclude the video. If you like my videos, please like, share and subscribe. Thanks for watching.